Question number 22, the last one. Find the Taylor series of f of x is 1 over 2x minus 3, centered at c is equal to minus 4. What's the interval of convergence of the series? Okay, so because we're expanding around c is equal to minus 4 and not c is equal to 0, we're going to be expanding in terms of x minus minus 4, which is x plus 4 to the n. So what we want to do is we want to rewrite 1 over 2x minus 3 so that we aren't treating x as a single little blob, a single quantity. We're treating x plus 4 as a single little quantity. How do we accomplish that? Well, we have a 2x, but we want to rewrite this as, let's say, a 2 times x plus 4. And that is 2x plus 8. So that suggests that we should add 8 and subtract 8 from the denominator so that we can rewrite in terms of 2x, of x plus 4. So 2x plus 8 minus 3. Those are equivalent. And I'm just going to continue to manipulate f of x in a bunch of different ways here. So I can combine... I can rewrite this as 1 over 2 times x plus 4 minus 11. And now I'm going to make one more cosmetic change here. I'm just going to reverse the order in which I'm writing the two terms downstairs here. Why did I just do that? Because I'm aiming for 1 over 1 minus z is the sum of, from 0 to infinity, of z to the nth power. So I'm going to try to make this look like this, and to do that, I need the number where this minus 11 is to become a 1 in order for things to work out. So how do I accomplish this? I'm going to factor a minus 11 out from the denominator. And so I end up with 1 over 1 minus 2 over 11 times x plus 4. So if we multiply back through by minus 11, we end up back here. So it might look like that we're making this more complicated than it originally was. However, we now have it looking very much like this. So we're going to plop in z is 2/11 times x plus 4 into our series right here. And that's going to give us minus 1/11 times the sum of n from 0 to infinity of 2/11 times x plus 4 to the nth power. If we want to simplify this a little bit, we can simplify this. The sum n from 0 to infinity of minus, and then 2 to the n times x plus 4 to the nth power, and 11 to the n, but there's an extra factor 11 out here, so it's 11 to the n plus first power. That's what we end up with. So here's our Taylor series of the function center at c is equal to minus 4. So there's one more question that we have to answer here, which is, what is the interval of convergence? So the interval of convergence of this series expansion is absolute value of z is less than 1. Strictly less than 1. If absolute value of z is equal to 1, this diverges. So what we're going to do now is that we're going to plop in 2/11 times x plus 4, and this is less than 1. This is going to give us the interval of convergence down here. So rewriting this, we have x plus 4, absolute value of that is less than 11 over 2, which is dropping absolute value bars and replacing it with two inequalities. X plus 4 is less than 11 over 2 and greater than minus 11 over 2. And finally, if we subtract 4 from everywhere, we get x is less than 3/2 and greater than minus 19/2. So the interval, that is minus 19 over 2 to 3/2, that is our interval of convergence for this function, this Taylor series for this function centered at c is equal to -4. So, moral of the story here, we had to rewrite things in terms of x plus 4, make that a 1 to be able to use this formula.